friends, welcome back again. My name is Johannes. In this session we will see some compound channels and also composite sections along with equivalent roughness. So I think, what is compound channel? So compound channel is nothing. You have some portion which is deep portion and also flat plane. So a compound channel is a channel section which is composed of a main deep portion and one or two flat planes that carry high water flows. So this is the basic definition of compound channel. So let me show you the sketch. So this is just main deep portion. You have area, perimeter and roughness, and also left bank and right bank you have. So we have such type of cross section. So why we provide such type of channel? So if the flood goes beyond the capacity of the channel, we are forced to design a compound channel. So you have some cross-sectional which is region 1 and region 2 and region 3. So the main channel is region 2, and the flood plane on the left bank, leftover bank, you have channel 1 and channel 3. So we will calculate these areas. So actually the main channel carries the dry weather flow, and during wet season the flow may spill over the banks of the main channel. So during wet season, just flood may overtop to these flood plains, right or left bank, so to the adjacent flood plains. Then a majority of natural rivers have compound sections due to some turbulence and also some overtopping of the flood. So the main channel will have interaction with the flow in the flood plains, leading to severe momentum exchange at the interface of the two, the flood plane and the main channel. Further, there will be complicated interaction while the boundaries at the junction, which give rise to several sets of vortices leading to turbulence generation. So the velocity of the flow in the flood plane, which is on the left and right bank of this compound section, is lower than in the main channel due to the relative small water depths, since it is shallow and wide. So you have very less flow velocity and also high bed roughness, and you have depths. So we will compare this H and Y so that we can calculate different calculations. So you have methods for defining the boundaries of the subsections of the compound channel. How to define the boundaries? So we have vertical interface method, diagonal section method. We have vertical interface method. So this is just vertically you can draw such a drawing. We have to draw to this direction, which is vertical interface method. The flood banks are separated from the main channel by means of vertical interface. So you will draw line. So you have this region and this region. Then you will compute the area and other methods. And also we have diagonal interface method. So the diagonal interface is considered from the top of the main channel bank to the center line of the water surface, top water surface. So you have this center point. So you will just draw diagonal. Then we will compute such areas. Different areas will be computed. Then we can compute the discharge flowing through this compound section. So let us see now methods for calculation of discharge in compound channel section. We have two methods are available for discharge computation in the compound section. We have Partion method. The first one is Partion method. So in this Partion method, the discharge is calculated as the sum of partial discharges in the sub areas 1 to 3. So you will sum up areas and also velocity, etc., perimeter also. Then finally we will use Manning roughness, Manning equation. Due to different roughness, we can compute such discharges. So you will sum up. So this is Partion method. So in this method, you have just to compute cubic, which is summation of this discharge, or summation of VI, AI. So under this partial method, we have two methods, posi method and zero shear method. So in the posi method, the imaginary boundary inside the water is included as rough surface for the main channel. We will consider such areas, then we will include. But in zero shear method, imaginary boundary will not be included as rough surface for any subsection. So imaginary line which is drawing, once you have such a section like this, so this is the imaginary line you are just drawing. So then we have to include or exclude. So according to posi method, just the imaginary boundary inside the water is included as rough surface. For the main channel you will include, but in zero shear method, imaginary boundary will not be included as rough surface for any subsection in zero shear method. We will not consider this imaginary lines. Sometimes you may use such diagonal again, then we will not consider. So in posi method, you simply just P1, for example, LAB, which is, let me go back again to the previous slide, this one. For example, in posi method, P1, which is perimeter of this one, which is AB plus BC, which is just a boundary which is going to be added, and you can have P2 again for this region. We have to include just KC, imaginary line will be included. So you have KC plus KD plus CD plus DE plus DF plus FJ. You will include all this one, imaginary line will be included. But for zero shear method, you will not include. For example, for P1, you have AB, BC, but P2 will be for this perimeter, you start from CD. You start from this one. For zero shear method, CD plus DE plus DF only. You will not include this boundary, imaginary boundary line will not be included in zero shear method. So having this in mind, finally, once you compute area and also perimeter, you can find hydraulic radius. Then finally, using Manning equation, we can find discharge for each subsection. For example, for Q1, you have A1 over N1 Z R1. For each subsection, you will consider 2 over 3, then S naught to the power of half, bed slope, channel bed slope to the power of half. So like that, you will have for each region Q1, Q2, Q3, then finally you sum up all discharges, then you will have total discharge passing through the cross section. And in the whole section method, the discharge is also calculated by considering the whole section as a unity portion, A, B, C, D, E, F, G, H, A. All subsection as in figure previously, you will add, then finally you can reach at the point. So I hope once you have this one, then finally whole section method, you need to have equivalent roughness. So this will be not N1, N2, but you should have equivalent roughness should be computed. Let us see the methods for computing equivalent roughness of composite section. So a composite section is nothing, just a section in which the bed roughness or the roughness coefficient is different for each boundary along its weighted perimeter. So we will consider. So let us see. This is left flat plane, main channel in the center and right. So you have left roughness, you have one roughness here, then another roughness coefficient, you have Manning roughness, and the third one is this one. So you will have a composite method, so you should have equivalent Manning roughness. Using the following methods, we can compute different methods. The first one is Houghton's method. You will have Houghton's formula. Average velocity will be equal to subsection velocity, we will assume. Then we have this equation. So this is the general equation to compute equivalent roughness, summation of pi ni the power of 3 over 2. So once you sum up the whole 2 over 3 over total perimeter, which is summation of each boundary line, you can just sum up. Then the second one is Pavlovsky formula. This is total resisting motion equal to sum of subsection resisting motion. So you will use this equation for equivalent roughness, summation of pi ni square, the whole half or under square root over total perimeter, the power of half. And the third method is you will have Lothar formula. So total discharge is equal to sum of subsection discharge. So you will have this equation again for the third formula to compute equivalent roughness. So I think having this in mind, so once you use either whole section method or Partion method, once you compute total peak discharge, which is going through the compound channel, you will adopt the maximum discharge, which is going through the compound section. So you will adopt the maximum discharge. Either you select the whole section method or Partion method in the above equations. Then finally, you will adopt the best or the maximum discharge, which is conveyed through the compound channel. So once you compute the equivalent roughness, so especially this is just to use in whole section method, we will consider equivalent roughness rather than N1, N2, etc. We will use equivalent compound or composite or just equivalent roughness will be computed. Okay, so thank you for watching. Thanks for watching. If you have any question, please put in the comment section below for further clarification. Otherwise, we end up with this thinking. And thanks for watching this video. So this is all about today's lecture. Hopefully you liked the video. If you have any comment or question regarding this topic, please write down in the comment section below. I will reply on it. Please like, share, and subscribe this video to get more precise lectures. Thanks.